Hello everyone. This is a video about movement. Specifically, I just want to quickly review the very basic way in which we might write a program that deals with a shape moving around. We've looked at this in relation to variables in general, but there are just a few extra things that we can think about that will be useful moving forwards. Okay, so let's return to our basic moving circle code. Remember, we have a circle. It has an x, a y, a size, and a speed. I've started its x at 0 here because it's going to move from left to right. We create our canvas, set our background, and then we have this all-important line that makes the circle move, which is that we change its x position by adding its speed. And because we add the speed, its x position gets bigger, and if its x position gets bigger, it moves from left to right. And we can see that because we draw the circle on the screen and watch it move. So just a reminder, if I reload this program, it starts on the left because we set x to 0, and it moves towards the right, 1 pixel at a time, because that's what its speed is. Perfect. We also know that, for example, if I set it to move from the center and we set its speed to be -1, then it would move from right to left. There it goes, moving from right to left. Because we're subtracting the speed in this instance, we're adding a negative speed, a negative number to its x position gets smaller, and as its x position gets smaller, it moves to the left. And finally, if its speed was 0, well, it wouldn't move at all, because it's adding nothing to its position over and over again. Okay, so we know about that. The thing that I would like us to update is the name of this speed thing. So speed is a sort of an easy way to think about it, but really what we're talking about when we talk about the distance that something moves over time, each sort of frame or each time step, if you want to think about physics, the name for that is actually velocity. So rather than calling it speed in here, I want to call it velocity. And the important thing about velocity, and really the important thing about movement in general in this 2D space, is that you shouldn't just only be able to move on the x-axis, you should be able to move on the y-axis as well. It seems unfair to limit our circle to only moving in one line from left to right or from right to left. And so what we're going to do is add 2 more properties. We're going to add Vx, that stands for velocity in the x-axis, and Vy, that stands for velocity in the y-axis. Okay? These are very standard ways of writing that down. There are other ways of writing this, but this is a decent way to go. We could also write out velocity x if we wanted to, but this is just one of those cases where I think it's perfectly reasonable to use Vx and Vy. It is something that we might see in physics, for example. So because we've made these changes, we no longer have speed. We'll need to correct the speed thing here, right? So now it needs to be circle x is assigned circle x plus circle.vx, so we add the velocity of the circle to its x position, and we do the same thing for y now, because we can change its y position based on its y velocity. It's the exact same idea. If we go and look at it now, because its velocity is 0 in x and 0 in y, it doesn't move, because it has no velocity. Again, just as with speed, if we set its x velocity to be 1, it moves to the right. But now also if we set its y velocity to say be -1, then it moves to the right and up at the same time, which is to say it moves diagonally. And that's because its x position is going up by 1 every frame. That means it moves to the right because it gets bigger, and its y position is going down by 1 every frame because we're adding -1, and that means it goes towards 0 and then negatives, and that means that it moves up. Perfect. This is a very standard way of dealing with basic 2-dimensional movement in a program. So it's really, I wanted to show you this just because I think it's really worth knowing about. Okay, let's carry on. If we wanted this to be a little bit more interesting, and like this is it, by the way, this is the whole thing, just that you have velocity as one of the properties of your moving thing, and that you make sure that you update its velocity by adding it to the position before you draw it or do anything else like that. So if we then wanted to control this circle in an interesting way, or a more interesting way, we could start using conditionals to change its velocity. So rather than directly mess around with its position, if we want to change the way it moves, we would control its velocity. So let's use the mouse to do that. So if the mouse position on X is less than the circle's position. So if the mouse position on X is less than the circle's position on X, what does that mean? It would mean that the mouse is to the left of the circle, right? Because its position is less than the circle's position, and we know that as we move down in numbers, we are moving to the left. What do I want to do? Well, I could do anything I want, but I think a sensible thing to do would be to set the circle's velocity on the X to be -1. Oh, and let me, while I'm thinking about this, I'll just set its initial velocity to be 0 and 0. So if the mouse is to the left of the circle, set its velocity to -1, that would start it moving to the left, right? So if the mouse is to the left, the circle moves to the left. So we're kind of having it follow the mouse in a way. We can test this already, so let's go take a look. So let's reload our program. That didn't do what I expected it to do. I'm trying to understand if mouse... Oh, so you know what's happened here. So this is a good thing for us to run into. I'll leave it in the video. Because mouse X starts at 0, this is going to be true the very first frame of the program, wherever I put my mouse. And so it's going to set the velocity to be -1, and then it's going to stay at -1 because there's nothing else that changes it. So that's a funny thing to have happen. This sort of thing happens all the time in programming. So let me add the other part of this. Else. So if the else here would be that the mouse X is greater than or equal to the circle X, right? So that would mean that it was to the right of the circle, and so we could give it a positive velocity. So if it's to the left, it goes negative, which means it moves left, and if the mouse is to the right, then it becomes positive and it moves to the right. So my mouse is on the right side here, so the circle is moving to the right, but if I move it to the left, the circle follows, and it's following very nicely. Very attentive. Okay, and then it stopped. We probably would like to do the same thing for the vertical position, for the Y position. So let's say if mouse Y is less than circle.Y. So if mouse Y is less than circle.Y, then it must be higher up on the screen, right? As the numbers, if circle Y's pixel value is bigger than the mouse Y pixel value, then it must be higher up, because we know that 0 is at the top of the screen, and the numbers go up as they go downwards. So if it's above it, let's tell it to have, again, a negative Y velocity so that it moves up. And otherwise, the mouse must be below it, because that's the only other place it could be, and we'll give it a positive Y velocity. So now the circle can follow the mouse. Here it comes, down from the top right. And as I move the mouse around it, you can see it follows. Just like that horror movie, it follows. Quite slowly, but it's doing its thing. Perfect. That is quite satisfying, I would have to say. Another thing, we've got these numbers now, but clearly we really ought to have a speed back again. So let's have a speed that the circle moves at. Let's make it move at 5, so that it's a bit faster. And instead of setting it to -1, we'll set this one to negative circle.speed, so it becomes -5 if I'm to the left of it, and we'll just replace these things again. So if it's to the right, I'm sorry, that was a horrible piece of pasting. If it's to the right, we'll set it to circle.speed, so it moves rightwards. Same thing here, negative circle.speed if it's above, and positive circle.speed if it's below. So now it moves at a much greater clip. I will leave you to think about why it is madly jiggling when it catches up with my mouse. Notice too that it's a lot harder to avoid the circle now. Like, this is starting to feel like my mouse is being pursued by this circle, which is quite nice. I mean, it starts to seem like I don't want the circle to reach, especially since it jiggles in a worrying way when it does reach my mouse. So these are the kinds of things that we can start to think about as we play around with these sorts of pieces of programming. Okay, so we've got quite a nice program now that sets up a circle. It's got velocity and speed now. It starts off not moving. We've got some code that controls the circle's velocity based on where the mouse is relative to the circle. And then we've got the important code that updates the circle's position with its velocity so that we actually can see it moving around as it moves. And that is it. Like, this is really, this basic, the most basic part here is this idea that we have a velocity as one of the properties of our thing that can move. That's what defines the fact that it can move, really, is the fact it has a position and a velocity. And the other crucial thing is just this little piece of maths here that we add the velocity to the position each frame, and that is what causes it to visually move across the screen. That's all that we really need to talk about. So you could stop here. The thing I would like to do, just because I think it does look so cool, it's in the too much information section of the lecture notes, we could add the idea of acceleration to this. So instead of controlling our circle's movement by directly setting its velocity, another thing that we might do is we'll add in two more of these properties, AX and AY, which stands for acceleration in the X and acceleration in the Y. And we'll, instead of speed, we'll have an acceleration, like how fast does our circle accelerate up to speed. The other thing that we may now want, because we've got acceleration, is we might want a maximum speed that our circle can travel at. And let's set that to be, I don't know, 5, 10. 10's good. Oh, I did a semicolon, idiot. So now our circle has gotten a lot more complicated. I'm assuming that you can drop out of this if you're not interested, but this is a cool thing. I think the results are really worthwhile. So we've added acceleration in the X and Y. So this is how fast the velocity increases. So we're kind of taking another step along from velocity. We have how much acceleration adds to the velocity each frame that our circle is accelerating, and we have a maximum speed that the circle can travel at so that it doesn't kind of become arbitrarily fast. So if we want to change our program to use these things, instead of setting the velocity in each of these places with the mouse, we should set its acceleration instead. So we'll set its acceleration in X to be circle.acceleration. And really, it's just the same thing, right? Its acceleration here should also be circle.acceleration. Same thing for Y. Perfect. It's just like cooking, isn't it? Not really. So now as the mouse moves to the left and right of the circle and above and below the circle has its acceleration set so that it will try and pursue the mouse. And we need another extra layer of maths here. Because now we're not just directly setting the velocity, we want to set the velocity via the acceleration. So the way that this works is that you say that the circle's velocity is equal to its velocity plus its acceleration. That's as simple as that. I mean, it's not as complicated as you might imagine. And we do the same thing for Y. So this is exactly the same math as this one here, right? Except here we're setting the velocity to add on its acceleration, and here we're setting the position to add on its velocity. So it's two steps now. The other thing that I said I would do is to do with the maximum speed. So I don't want its velocity to get bigger than the maximum speed. So I'm also then going to constrain this. So circle velocity X is going to be constrained. So I'm going to constrain the value that's inside circle.vx to be between the negative maximum speed and the positive maximum speed. That way the circle's not going to get really, really, really fast, which might be, and it's something that you could look into, but things that can become arbitrarily fast get a little bit less interesting to play around with. We want to do the same thing here for its y velocity as well, between negative circle.max speed and positive circle.max speed. Okay, there's quite a lot of stuff going on there. Let's go and take a quick look at what it looks like, assuming that it works. Now, let's reload. So there it is. So you can see that this lends a really different kind of feeling to this program, right? You can see, for instance, that it accelerates towards my mouse, but it overshoots because it's going so fast. And because it has to decelerate before it can turn around, it can't just instantly turn around as it did when we just set the velocity, you get a much more kind of lifelike feeling behavior. And clearly we can tune all of these sorts of things based on the maximum speed, the rate of acceleration, for example. So if, for example, we wanted it to accelerate a bit faster, we could change that, and we could also set its maximum speed, for instance, just to be a bit smaller. So now you can see it's got a much tighter speed at which it can turn around, and it also just doesn't get quite as fast, and I can kind of slingshot it around, which is quite satisfying. And this really, I think, when you add acceleration to basically a little physics simulation like this, it starts to get really satisfying. It's surprising just what that extra one layer of input can really do. You can see now it's going to kind of jiggle around forever around my mouse. So what did we add? We added to our velocity, well, first of all, we added this idea of velocity, which just controls the direction that our circle is moving in. We add that velocity to the position every frame. That's how it actually moves its position. But then we went one step further and we added an acceleration, which is what changes the velocity every frame, each time step, by adding some amount or subtracting some amount to the velocity. And that's what gives us that little bit of extra kind of nice fancy movement. And as we saw, we do exactly the same maths. We add the acceleration to the velocity every frame. And here I'm constraining the velocity afterwards so that it doesn't get too big or too big in the negative or too big in the positive by using the constrain function. The other thing that we just did was that we actually controlled the acceleration, which direction the circle was accelerating in, based on the mouse position, just as we did for the velocity prior to that. So I spent a little extra time on the acceleration thing there. I just think it's so cool. It's such a beautiful way to look at movement. It does complicate things, so there are reasons to be wary of it, but it is super beautiful to look at, and you might want to play around with it. So now you have it. Okay, I think that's it from me for this video. We'll use this movement stuff going forwards. I'm sure you'll use it in many projects. It can lead to all kinds of fun and interesting visual and movement effects. It can be very beautiful. Okay, see you on the other side after we escape from this terrifying tunnel of windows.